Hi everyone, welcome to today's session. My name is Sri Krishna. I am your learner success manager for the day. Before we go ahead with the session, please let me know if my voice is loud and clear. You can confirm in chat box. Thank you for your confirmation. Hi Rahul, for audio confirmation, let me know if my voice is loud and clear.
Yes, your voice is loud and clear, Shri Krishna.
Yeah, thank you for your confirmation. Now I will make you the presenter so you can get started with the session. Happy learning everyone.
Thank you, Shri. So, hello everyone. I hope everyone is doing well. Let's wait for people to join in, and then we start with the session because the strength is very low. Hello everyone. Good morning, good afternoon. I hope everyone is doing well. And I hope I'm audible to everyone. Afternoon. Okay, perfect. So just a verbal recap of what we did in previous class. So in previous class, we started talking about uh, initially what libraries are, where do we install them. So a good introduction around libraries and all the components around it. Post that we started talking about NumPy library and how it is important. And then post that we started talking about pandas library. We went through the page. I also gave you the importance of pandas, and we also talked about a project, like how does a usual life cycle of a project look like. Correct. I've also shared those notes with everyone on your LMS portal, and we started with the pandas library then, and that is where we stopped. We talked bits of parts around pandas, and that is where we stopped. And of course, we'll be continuing from there only. So, any questions anyone having, please put in the chat before moving ahead. If not, please write clear so that I can get as a confirmation that everyone is clear till this point and no questions from anyone. Okay, perfect. So let's move ahead and then let's talk about pandas. So let me open up the code. Let me share the screen and let's continue with pandas where we left off. Okay, and we'll hope to complete pandas during today's session and then move further on. So please give me a second, launching the code and sharing the screen. I hope my screen is visible to everyone. Okay, perfect. Okay, so we covered till we started from the top. Just to give you a recap of what we have done so far in pandas as well. We started with pandas and we started talking about series, one of the data structures present in pandas. And we looked into how we can create a series, how we can do indexing on top of series, and arithmetic operation between series, followed by certain functions like head, tail, and dim shape. And then post that we talked about data frames, how they are different, and how do you read a file from uh, your system or any particular location into pandas. So we looked into that part, and then post that doing looking into the various functions on top of data frames as well, and them shape, head, tail, d types, info, memory usage. So we looked at a lot of functions, how to select a column or multiple columns, and how to get the unique values, value counts, create a new column by simply assigning a value or doing arithmetic operation as well, and then how to drop rows and columns as well. We looked into that, and post that, then we started talking about how do you do selection on the data using .log, .ilog, what is the difference between them, .at, .iat, what is the difference between them. So we looked into those things as well, and then post that we just simply looked at uh, some arithmetic operations, if I'm not wrong, but again we can cover these. It's barely few things, and then is where we'll be moving ahead. So I hope till this point everyone is clear. Let me run all the cells above so that all the columns and everything is created. Data frame is read in the memory. Okay, so let's move ahead now. So what we are doing now is pandas also supports multiple arithmetic operations as well. For example, here I'm saying df total bill, tip, and size. I want the mean for them. So if you simply say, first of all, this command, what will this simply selected command give me? Can anyone tell? Like simply the highlighted area. If I run this, what will I get? Yes, it will select those three columns and the output will be a data frame. Output will be a data frame, okay? Because if we select one column, it is a series. If we are selecting three columns, it's a data frame, as you can see over here. Okay. So yes, I'm saying for these three columns, because on top of data frame, you can do the mean as well. I want the mean. So it says that okay, for total bill, the mean is 19.78. For tip, 2.99. For size, 2.56. You can do it for individual columns as well. Means what I'm trying to say that these arithmetic operations are not simply bound for data frames, they also work with series as well. So total bill, median, median, sum, standard deviation, cumulative sum, and there are many more. Just if you simply press tab, there are many more arithmetic operations that you can do. A lot more arithmetic operations. Okay, just let me press over here. So a lot more arithmetic operations, argmax, argmin, okay, a lot more arithmetic operations, count, that you can do over here. Now, I also have recommended all of you to please start going through Pandas documentation. So I'm hoping everyone has already started that. And because again, just stating the relevance and importance of this library is why I'm asking all of you to do that. Okay, so this is my data frame still. Now we'll look into how you can select data based on certain conditions. Okay, how condition selections. Just give me. Okay, so now I want to filter data. Now, and this is one of the most common things you would want to do. And you would often do this in Excel as well by simply applying filters for a particular row, selecting only particular values, for a particular column, selecting only particular values, and the corresponding data shows up. Now, for example, I would want to simply select all the entries where the gender is male. Am I audible to everyone? Okay. Okay. So let's say I want to only select entries where the gender is male. So if I say df gender is equal to male. Now do remember Python is case sensitive. Everything has to be in exact same manner how it is. Okay. So df gender is equal to male. Once you run this, it only shows you a Boolean series. Wherever the condition is true, it shows true. Wherever the condition is false, it shows false. Does this behavior look similar to NumPy, like how we were doing filtering in NumPy? What do you say, everyone? Correct. So in NumPy also we put in a condition a greater than 4, and only those uh, values were coming well returned as an output where the value was greater than 4 in fact. Okay. So that is what is happening over here also. If I say df gender is equal to male. Okay. And if I simply index it like df square bracket and simply stating df gender is equal to male. Now if I run this, it will only select and return you the data frame where gender is male. You see this? So 157 rows and 8 columns. Now it is filtering the data and returning you. Means, does it change the original data frame? The answer is no. Your original data frame still has all the rows, everything. When you're putting this condition, and of course you are not writing overwriting df. What if I would have said like this? What do you think what would have happened? Df equals to this way. What would happen in this case? Correct. Her original df will be simply overwritten by a data frame in which only male gender is there. Okay. So that is what eventually happens over here. But in this case, because I'm not assigning it, so it is simply return me a data frame. Now, of course, you can save it in any new variable or simply overwrite your existing variable. That's totally up to you. So I'm saying male df is equal to df gender is equal to male. Okay. So male underscore df, this gives me a data frame in which only the entries are male. Okay. Now, just to show you that you can do n number of nestings. When I say nestings, means you can do whatever you would want to do. For example, I'm saying df gender is equal to male. So now this only selects the data for male, correct? What is happening above? Now I say that I only want to select these 3 columns. That can be done. Okay. So yes, it only selects, sorry, these 2 columns, it only selects the 2 column on top of the male data frame. Do understand that first male data frame is selected. On top of that, then these 2 columns are what you're selecting. On top of that, let's say you're saying now, I want to look at only top 5 rows. That you can do. On top of that top 5 rows, now for these top 5 rows, give me the n unique values, number of unique values. So it says for total will 5 unique values, percentage with respect to total will 5 unique values. Does it make sense? So what I'm trying to show is you can do n number of nesting on top of each other by in a single line itself. Okay. Questions, anyone? Okay, I hope no questions. Let's move ahead then. Now, for example, you put in a single condition. Now your question would be, what if I want to put multiple conditions? I want to select data based on multiple filters. Can I do that? The answer is yes, you can do that. How? By simply using ampersand sign or pipe sign, which correspond to the and the or arithmetic or logical operators, sorry, the logical operators. So what I'm saying over here is now If you look closely, please give me a second, everyone. Okay, so what is happening over here is I'm saying select data where gender is only male and this is and. So in pandas, instead of and, we tend to use ampersand sign. Okay, and smoker is equal to no. So it will only select the data frame where gender is male, as you can see, and smoker is no. So only these unique values will be permitted in these two columns. Why? Because that is what you have put over here. Okay, gender male and smoker no. Now when you run this, it will return you the data frame where these both conditions are met. Hence 97 rows and 8 columns. Now you need to pay attention to one particular thing over here. When you're having a single condition, you can directly put it inside the square brackets, the indexing brackets, correct? But if you're having multiple conditions, you need to put small brackets like this for every condition. So small brackets, and of course these will go inside the square bracket. I've added the space over here just for the readability, readability, but usually we do not tend to keep unnecessary spaces. That's not a recommendation. Okay, so df gender is equal to male and df smoker is equal to no, and both the conditions are in parentheses. Without the parentheses, it will not give you the desired results and might also give you an error. So keep that in mind. Okay, so now you might say that what if I want to put n number of conditions? Can you do that? The answer is yes. The answer is totally yes. So saying df gender is equal to male, smoker is equal to no, total bill is greater than 15. So once you run this, what will happen? It will show you all these conditions. Now your question might be, can I do multiple conditions on a single column? What do you think? Can we do that? Should pandas allow it? What's your opinion? Correct. Pandas will allow that as well. Okay. So you are saying where gender is male, smoker is no, total bill greater than 15, but less than 15.5. So only two rows. Okay. So you can do this n number of filtering as well. Okay. Do keep this in mind. So it's very flexible and it allows you to put multiple conditions in a single uh, line. Again, I have simply put in multiple lines for the ease of readability. You can have them in one line, that's not an issue. And also you can have n number of conditions and n number of conditions on top of a single column as well. Okay, so all those things are possible. Okay, now this is how AND condition is used, where everything has to be satisfied. And this is what mostly you all will be using. Okay, you will be using this only nearly all the time. But we also have a OR condition. So gender, male, pipe. Pipe refers like this is a pipe sign above your return or enter key on your keyboard. So you simply use shift and then press that above key and it gives you this pipe sign over here. We call this sign pipe sign. Okay, so pipe sign is usually is it refers to the OR symbol, or you can say the OR logical operation in pandas. So I'm saying gender is equal to male or smoker is equal to yes. It is not and. Hence the results are very different. Means, let me tell you what I'm trying to say. For this, what you are trying to get, have a look closely. Just let me zoom a bit. Now we know that either male or yes. So male or yes. One condition has to be satisfied. Okay. So in this case, male yes can be present, male no can be present. Correct. Now for yes, I can say yes, female can be present because still one condition is met, but no female. Do you think this condition will be allowed? Like this combination will be allowed? Is any condition met over here? So this is not allowed. So all these three conditions will be present over here in this data frame. At least one condition has to be met. That is what OR does. Okay, clear? So that is what will be the output over here. So you'll see all the combinations except female and no over here. You'll see female and yes, as you can see over here. Male yes, male no, except female and no. Now you might say that I can simply do this uh, condition using and as well. Yes, you can do that. You'll have to play, of course, with certain caveats where and is equal to male and smoker is equal to yes and no. Okay, so we can do that as well. But again, how you can do it in OR, this is how you'll be able to do it. That at least one condition should be met, that either person is from India, location India, the username is correct, so allow the login that particular way. Any of the condition is met, things will happen. Questions, anyone? Okay, perfect. And does this alter my data frame? The answer is no, it does not. Please keep that in mind. Okay, so DF is still. Okay, now comes to the sorting of the data. This again is very important. Now what we are doing over here is I'm saying I want to sort my data based on a numerical or based on some string values. Can I do that in pandas? The answer is yes, you can do that in pandas. How do you do it? By simply using the function dot sort underscore values. Dot sort underscore values. That is how you do it. So if I show you, so I'm saying df dot sort underscore values by means which column you would want to use for sorting. Now your question would be, can we do it with respect to multiple columns? Yes, I'll be showing you that example below. As you can see over here, we'll be discussing about that as well. Now question would be, can I do it in ascending, descending order? Yes. For example, when I'm saying ascending, again an argument inside the sort underscore values function, ascending is equal to false means I want to sort my data frame df with respect to this particular column in descending order. In descending order. That is what I'm doing. Now in place is equal to true. Can you tell what this argument is doing over here? We discussed this in place argument inside the drop function as well, if you recall it. It makes the changes to the data frame itself. Correct? Do you remember it? Makes the changes to the data frame itself. So when I run this, you can see that my data frame is sorted with respect to this percentage with respect to total bill column. And the highest value comes on top, lowest value comes at the bottom. Okay. Same way, now we can do with respect to these two columns as well. For example, you are saying df.sort underscore values by percentage with respect to total bill column, and the second one is tip column. Now the question comes, can I do different orders? When I say different orders means different sorts with respect to the column. For example, I want to do ascending sort with respect to the person tip, and then the descending sort with respect to the tip column. Can that be done? The answer is yes, it can be done. How? By simply specifying that as well. So what you are doing over here is you're saying, just let me bring in the pen. So you're saying that sort the data first with percentage with respect to total will in descending order and with tip in ascending order. So you need to provide in a list as you can see closely. So you need to provide in a list and it will be doing that particular thing. Okay. I hope this is clear to everyone. Any questions? No. Sayed, ascending is the only argument in the sort value function. So try to think it like you made a function sort underscore values and you only place in the argument name as ascending. So it's not that descending is a name you would want to choose and you can put that. No. While when this function was defined in the backend of pandas, they use the ascending name as the argument name. Okay. So if you recall how functions are defined, you'll be able to read it. Okay. Okay. Moving ahead. Now, if you see that after sorting, is my index shuffled up? Answer is yes, correct. The index is shuffled up. So first, now the question would be, I want to sort the index. Can I do that? The answer is yes, you would want to. You can sort the index as well. How? By simply saying df dot sort underscore index. It sorts the index. Hence, you'll be getting the original values back again. Like the whole original structure of the data will go back to its structure. Why? Because that was the original structure. But does it make the change in the data frame directly? The answer is no. Okay. Now your question would be that okay, I want to keep this ascending or sort order, and now I want to reset the index from 0 to 1. Like this should be my row number 0 now. Can I do that? Yes. How? By using the reset underscore index function. We'll talk about that. So if impulse can change data frame, so can dot txt value change will change. What is impulse you're referring to over here, Abhay? See, okay, I have already told this in previous class. If you are making any changes to your data frame over here, this is not connected live to the file that is present on your system or anywhere. Once you run the function df pd dot df is equal to pd dot read underscore csv and read the file, the whole data is simply copied from the file and brought into the system's memory. Okay. Now you can delete that file. Doesn't matter because the data is already present in the memory. We will make n number of changes. It will not be happening in that particular file if that file is present. Okay. So it's completely disconnected with that file now. Okay. So df.index. Now the question is, for example, that I simply sorted the values up and down, and now I want to see that okay, I want to sort this index. I want the counting again to start from 0. Just for the sake of some operation that you are doing. So can you do that? The answer is yes. How? By simply saying, first of all, df.index function is simply used to get the index of the function. We have already seen this. But how do I do this? By simply using the function df dot reset underscore index. Once you run this, you can see that the index is again reset from 0 and my highest value is still present. But a new column has been added, index, in which all the older indexes are present. Usually, this is what sometimes people tend to do. Hence, that is the intent of pandas over here as well. That people want to keep the original indexes or IDs along with the whole resetting so that they can use it at that. Okay, this was which particular row earlier. Now, what this row has become. So that is the intent of pandas also over here to simply store the old indexes. But now your question would be that I do not want this. In that case, what should I do? And also to mention that if I've done reset index, does it change my original data frame? The answer is no. You always have to put in place, then only the index will be changed. To keep that in mind. But now your question is that okay, I do not want this index column to be created when I reset the index. How can I avoid that thing? By simply using the argument drop is equal to true and df.reset index drop is equal to true means it will not be storing the old index. It simply drops it now. Okay, it will not be storing it. And empty is equal to true. And once you do this, now you can see with the highest value, the index is 0 and I do not have any index column. I do not have any index column. Questions, anyone? Please put it. Okay, I don't see any questions coming up, so let's move back. Now there was a question initially, if you remember, that okay, pandas shows does not show all the rows and instead shows these dots just to show you a snapshot of your data frame. Now please listen this carefully. It is important for those who are completely new to programming and these things. See, showing all the rows is never good. Why? First of all, if let's say if your data frame is having thousands or 10,000s or millions of rows, and when you simply run this df thing, and it should show all the rows, it consumes memory. Okay, it's not a memory free function. Okay, it will consume memory. It will, when it prints, the file size of this particular file where I'm programming grows very big. Okay, first, should you do that? The answer is no. Why? Because the file size of this will grow, Jupyter or your system's memory will be consumed as well. Okay, and when you try to reopen this file after closing, because the file size has grown so much, Jupyter Notebook or any other IDE will be facing a lot of difficulties or struggles in opening up the code itself, in fact. So it's always recommended to never see the whole files. And that is, in case if anyone is from SQL as well, can also confirm that usually the settings is only set for top 10 rows, 20 rows, or 100 rows. Whenever you run a query, only the top 100 rows after your operations are shown, not the whole data frame, which can contain millions or billions of rows. Okay, that simply breaks everything then. So that is the case. Correct? So hence now the question would be that okay, I want to see certain more number of rows. How do I do that? By using the pandas functionality. By default, the maximum number of show rows without a dot that will that you can see in a single go is 60 rows by default. There is an option pandas has set at the backend that you can only see 60 rows, but you can extend this. You can say pd.options.display.max rows. Let's say I'm saying 300. That maximum number of rows that I can see is 300. If the rows are more than that, then it will start showing me dot 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 like this. But if it is less than 300, it will show me all the rows in a single go. pd.options.display.max columns. Like if there are 100 columns, it will not show me dots. Otherwise, how we are having dots in rows. Same way, you also see dots in columns if there are multiple columns. So same way, You can also specify how many columns you would want to see. For example, I'm setting this as 30. And because my total number of rows are 244, so it should show me the whole data frame, correct? When I run simply df. And that is what it does. You see now it will show you the full data frame. You'll not see any dot in between. Are you seeing this? So the whole data frame is printed in a go. But again, not an ideal thing to do. So I'm simply saying that only 30 rows. So hence now because rows are more than 30 for my this particular input to Jupyter, hence it puts in the dots in between. But again, just to show you this as well. Any questions, anyone? Okay, let's move ahead then. Now, I would want to check missing values. What if my data frame has missing values? How do I check for those? Yes, you can do that protect you by simply using the ilog or log or any other program code that you would want to use. You can do that. Okay. Now, coming to next part. Now, what if you would want to check if your data frame has any missing values or not? So, if you remember, we talked about yes, the display option is simply that how many rows should be shown. But if you want to select certain middle rows, apply some filters on top of it, that is simply done using selection of the data because you're selecting the data. This is simply a view of the data. This is what your data is. Now I can determine when I want to have a view or a operation that okay how the operation is working. For example, here I'm simply looking at my whole data frame, but could be I might do some operation and that returns me multiple rows. So this is simply limiting how many rows will be shown or how many columns will be shown to the minimum level. That's it. Okay, coming back to the dot is any. Now we have already talked about that the data frames can contain missing values. Correct? What are missing values? Where the data is simply absent, no data is present. That is what is a missing value. So can we do we have a function that can help us figure out how many missing values or absence of data is present in my data frame or in my file, of course, because it's simply a replica of your file. So the answer is yes. How? By using the dot is any function. Now what does dot is any say? It tells you whether it's a missing value or not. Once you run this, you can see that you are having a Boolean data frame, correct? Wherever now of course in this case everything is false in front of us because there is no missing data. Everywhere a data is present, you can see that, correct? Hence, so is it any? The answer is no. Let that okay. This is not of any value. This is also not an any value. Means it's not a blank value. Okay. So df dot is null or is any one and the same thing, Arpita, in fact. So df dot is any. It tells you that if there are any missing values or not in your data frame, it returns your Boolean data frame. False true, false true. Wherever there is a missing value, it says it's true. Wherever a false value, it says it's false. Now the question is that okay, how do I start looking into number of true in present in a column? My data frame can have n number of uh, rows, correct? So it's not feasible as well as possible to simply count the number of trues or false present in the column. I'll have to write a code around it. Okay, correct. But that can be solved with the help of a clever functionality. Now, if you remember, I've told you that false indicates 0 and true indicates 1 at the back end, correct? Do you remember this? Means if I say false plus false plus false plus true, the output should be 1. Why? Because essentially I'm saying 0 plus 0 plus 0 plus 1. Okay? Hence you can see the output is 1. the output is 1. Please give me a second, everyone. Okay. So when I'm doing false plus false plus false plus true, so give me a second, please. Okay. You can see false plus false plus false plus true, so it gives me 1. The same way, what if I do a dot sum on top of this Boolean data frame that is returned by the isAny function? So it will help you to figure out how many trues are present in this column, correct? And what does true indicate? True indicates the missing value presence. Hence, when I say df dot isAny and I do a dot sum on top of it, so it simply sums up the whole column and it tells you the count, or you can say the number of trues basically that are present. Why? Because every true is equal to 1 and number will be equal to how many times true has been added. That indicates how many missing values. So it says for total will and all the columns, there are 0 trues, essentially 0 missing values in my data frame. 0 missing values in my data frame. But now because we'll have to study, so what I'll do, I'll create a data frame and manually enter missing values over here. Okay, so what I'm doing is I'm making a data frame, pd dot data frame, data, column A, and these are the values in column A, 10, 3, and none. So none is the Python keyword indicating a missing or blank value, a none type, like nothing is present. Same way, B column 9, none, none. C column 15, 20, 35. Okay, np.nan also indicates the null value. I've stated these things over here itself in a comment. Okay, so if you see the null here, do you see this nan value? So this nan value is simply a indication that it's a blank data over here. That is a blank data. Keep that in mind. Now your question would be why everything has been converted in column A and B to float value. Can you answer this? Because I've already answered this. Whereas C column is simply an integer. Why column A and B, 10, 3, and 9 have been converted to float? Can you tell? Okay, because by default in pandas, any blank value or null value is treated as a float data type. And pandas tries to keep a common data type in column. And if possible, it will do that. For example, can integers be converted to float? The answer is yes. Null values are already float. So what it will do, it will try to convert integers to float so that the same data type is maintained across the column. Okay. And that is what you can see is happening over here. That is what is happening over here. 10, 3, and 9 are converted to float, and nan, which is by default treated as a float data type in pandas. Okay, so just to maintain the similar data type in A and B, they've been converted to float completely. Now, if I say a null df dot is any, you can see that wherever there is a missing value, a true is placed over there. Correct? True, true, and true. Now, if I simply say dot is any dot sum, It simply is doing a sum on top of every column. So it sees for column A, one missing value, column B, two missing values, and column C, zero missing values. Essentially, it is simply returning you the sum of all the trues present in that column. But we know that wherever a missing value is present, then only it will be showing the value as true. Okay. Now the question comes that okay, this is how it looks. Now, if what do you tend to do with drop? What do you tend to do with missing values? There are two particular things that we do with missing values. First, either drop them, means remove them from our data frame. Second, either fill them with the most closest value possible or a sensible data possible. That is what we tend to do with missing values. Now, let's talk about the first method. How do we drop the missing values? By simply using the drop any function. Okay, so I'm simply saying df dot drop any, and you can see only one row is left. Now, can you tell me why only one row is left? Why the values, these values are not present? Can you tell me that? Anyone? Just try to think about it and give me answer. It has a very logical answer, in fact. Of course, that is what is happening. That row is getting dropped even if one column is NA. But why? Why can I not have this 3, 2, and 35 still present? And only the null values drop. Anyone able to answer this? See, for example, let's say this is your Excel file. Okay, this is your Excel file. Okay, this is your column A, B, and C. And you put in values 10, 3, 5, 15, 20, 35. Now, if you look closely, what is happening is that already there is a missing value over here, there is a missing value over here, there is a missing value over here. Means your data is already in this shape. Your data is already in this shape. Correct? But what is a structured data? Equal number of rows, equal rows, and equal columns. Correct? Means if my data is still present till over here in column C, so this will be a row. And also you can see the data is present over here. So how can I say that okay, I will take the data like this? It is still present and then only because ultimately my data is divided like this. It has to be structured. If our data is present over here, to say this whole thing will be treated as a row. Correct? Getting it? Does it make sense? So it's not possible for me to say that okay, I'll remove this. I can remove this. But is it a structured data frame? The answer is no. It is not even possible. Because if I'm removing this, this is still blank only. Correct? Let's say I remove this. So I'm saying 10, 3, 9, 15, 20, 35. But are we having any data still? The answer is no, it is still blank. Getting it? It is still blank. So even if I remove these, first of all, that's not possible because we have to have equal number of rows. It's not that for column A, I'll have 15 rows, for column B, I'll have 20 rows, for column C, I'll have 100 rows. That's not possible. We tend to have equal number of rows for all the columns. Correct? That is what is a structured data frame. That is what a structured data frame is, Toby. That is what is a structured data is. Equal number of rows for all the columns. So that is what is happening. So once I say dot drop any, so it drops all the rows wherever a missing value is present. Because it cannot say, okay, for example, you are having, let's say, data like this 15, 3, let's say here is simply a blank value, 20, 35, 40, and let's say 8. Now in this case, if I drop this missing value, So 40 should move up then, correct? If I drop this missing value, so this is how my data frame is correct currently, uh, like this. And this middle value is blank, correct? This one is blank completely. Sorry, like this. This one is blank completely, correct? That is what is the case. So if I'm removing this, so should this move up? So then there will be a blank value over here. So first of all, equal number of rows for all the column. And even if I move this up, this simply change the whole data characteristics. How the data was, it will not be in that particular way now. Hence, it's not possible. Okay, so if you use drop any, the whole row wherever a missing value is present is dropped. Now your question would be that okay, even if a single missing value is present, we are dropping it. What if I do not want that to happen? There should be some number of values present, then that row should not be dropped. I want to do that. That this much values are present, doesn't matter how many missing values are there. But if this much number of values are present in that row should not be dropped. Can we do that? The answer is yes, using the thresh argument. So what you are saying that null df dot drop any and you're saying thresh is equal to 2 means that at least there are two values or two data points present in my row. That row will not be dropped. Does not matter if there are 1000 missing values, 1000 columns are there, and in 998 there are missing values, and only two rows, two columns are where the value is present for that row. So in that case, that row will not be dropped. Let me repeat. If thresh argument states that at least these much data points should be present in a row, in a NaN row, for it to be not dropped. Clear? Let me repeat. It states that in any NaN row, these much data points should be present minimum for it not to be getting dropped in this drop NA function. That is what this function is doing over here. Argument doing over here. Okay, so you can see that now in this case, it does not drop my second row. Why? Because there are at least two data points present over here. That's why. But does this drop from my data frame itself? The answer is no, it does not. It still shows you the return. If you remember, we talked about if you are getting output, means nothing has changed at the back end. If you are not getting output, then yes, there have been changes at the back end. That is how you can try to understand this. So now your question would be then how do I make changes to my data frame at the backend? Again, by simply using the same argument, employees is equal to true. You simply state that and it will be dropped. So this is the first part. If you're having missing values, you want to drop it. So dot drop any function. Now comes the second part. What if I want to fill the missing values? Now for filling up missing values, of course, you'll have to use your common sense, your brain to figure out that what value should be present over here. No one is going to tell you. You have to, as a person, as a person with brain, in fact, you'll have to figure out that in the project itself, what your data is. If a value is missing, what technique or what value should be like, because what would be the intent? If there is a missing value, the intent would be that you would want to populate it with the value which should be present over there. And if you are not able to get it very accurate to 100%, you would want a very high accuracy. So you'll have to use your own brain and logics for that. But the question comes, how do I put it? Like, how do I fill it? So I'm giving you the function for filling it by simply telling you dot fill any. So df dot fill any. Now you can put in any value that should be filled in place of NaN values. So you're saying df dot fill any value which can be used to fill. This is simply a string value basically. So when I'm running this, you can see wherever there was a NaN value, it has been filled with what? That particular value we used in the fill any function. Now your question would be, can I fill it with averages and these things? The answer is yes, of course you can fill it with any value. Average is simply a number only at the end of the day. So you can fill it with any value. But please keep in mind, the intent is always to fill the data with the closest possible value that should be there. Mean, averages, sorry, mean, medians, modes, These things are good, but again, just always try to use your common sense first. So null df, this is my data frame. Okay. Now for a column, how do I calculate mean? By simply using null df a dot mean. Now what I'm doing is I'm simply storing this into a variable a underscore mean, and I'm saying null df dot fill any and putting in a dictionary because I would want to do custom fills for every column. For a column, I would want to use, let's say, a mean, for column B some other value. So that is what you can do over here. So I'm saying for column A, use a underscore mean. Again, to calculate this, so you can see that it fills this missing value with 6.5. Okay, and my null df is still having this as blank. So how do you fill it? By simply specifying the in place argument. Okay, which is over here. Now there are other techniques as well for filling missing values. The default or common techniques again not does not give you always the desired results, but this is simply to remove missing values, known as forward fill or backward fill. Now what is forward fill? So you're saying null df dot fill any, okay, method is equal to forward fill. Now what is this forward fill? Look closely please. Do you see this nan value over here? And let me change the color. So we are having this nan value over here. So in forward fill, what happens? The previous values are filled till all the next values. Till a next value data point comes, let's say 30 is over here. And all these are nan, nan, nan. So everywhere the preceding value is filled simply. That is what is a forward fill. So when I do method forward fill over here, you can see that there was a missing value over here, so it became 3. And this will keep on going until a data point is present. Let's say 38. So till all the blanks and all the blanks are there in between. So all these blanks will be filled with 3. That is what is a forward fill. And you can see over here as well. For example, 9 has been filled over here as well and here as well. Hence 9 and 9. You can see that. So 9 in both the values. So you can see that. Okay. Same way, backward fill is there. Backward B fill B fill means the values that are present in next rows will be filled up to the will be used to fill the missing values. Okay, in our case, because we do not have any row below this, so backward fill will not work. But in case if that is the case, so this will be used to fill the missing values over here. That is what is a backward fill. Okay, so I hope everyone is clear. Again, simply doing the in place changes and it shows you this particular thing. So till this point, I think everyone is clear. Any questions, everyone? Any questions, anyone? In forward, it will be 99955 like this. In backward, it will be 9555 and nan value again. Ankit. So in forward fill, the previous value is taken to fill up the values, and backward fill, the next value, like the front value, is taken to fill backwardly. It will not take in backward, it will not take. I did not say that. In forward, just to mention, it will be, for your example, in forward fill, it will be 9, 9, 9, 5, 5. Okay, this is forward fill. And you can try this as well. You already have the Excel, this code, or else you can make this as well, of course. simply try V fill and F fill. You can do that as well. But in backward fill, it will be 9, 5, 5, 5 over here, and a simple line over here because we do not have any next value. Okay. So let me do one thing. Let me, before moving ahead, share this code with everyone. Please do the revision till this particular point, that is till the null value handling, and then we'll move ahead. Once you are done, please write done so that I can understand that all of you are good till this point. And the intent, of course, you getting it and understanding it closely. Because again, this is an important library. So let me share this code with everyone on the chat window as of now. Of course, I'll be uploading it to the LMS portal. So please go through the code from starting till this point. Try to play around with various functions. Try to play around with data. Then only believe me, until unless you start pressing keys by yourself, try to play around, you won't be able to remember these things. So try to do those things till the null value treatment part that we have done. And once done, please write done so that then we can move ahead. I've already shared the code in the chat to everyone now. Please give a thumbs up to the code file if you're able to download it. Yes, Toby, it will only fill the missing values, like the blank values in the column. If you are for doing forward fill, so only the missing values are filled with the previous value, like previous data point, valid data point. Okay. And if you are doing backward fill, so missing values are filled with the next valid value present in the data frame. You can try it, like I would share the file. So do one thing, try to make a data frame in which in between there are missing values. Just make 4 to 5 rows only. Add missing rows in between and then try forward fill and backward fill. You'll be able to see just by the output, in fact. If you go to the documentation, Ankit, by simply pressing Shift Tab inside the fill any, inside the method, you will be able to see the argument as bfill. Simply place the fill with bfill. But in our case, it will not work because we do not have a row next in which there is a data. So you can add a row and then check the bfill. So has everyone reviewed the code? Or still someone is reviewing? If you are done with the code, please write done. If you're still reviewing it, please write doing. So that gives an idea about if those are going and done. So that I can give the time accordingly then. Okay, just I think 1, 2 people are still reviewing. So okay, just 2 to 3 minutes more and then we can go ahead. Okay, so let's move ahead. Now let me share the screen and let's move ahead. Please give me a second. So my screen is visible to everyone. Okay, so let's move ahead now. So far we have seen how we can handle missing values. When I say handle, means either drop or fill the missing values. Now we'll be seeing how we can kind of work with the duplicated data as well. Now what is duplicated data? Rows which are duplicates. Now see, duplicates depends upon your data. For example, just please listen carefully, everyone. Let's say I have a data of a bank. In this case, if I'm having some certain entries, for example, uh, withdrawal of withdraw 100, let's say rupees or dollars, whatever you want to mention this that as a currency. Time, let's say, and please listen carefully. I just want to show some things. So let's say we are having a bank data. So 314, 100 amount withdraw. Okay. Same way, 314, $100 withdraw or deposit, or again and again 314. Let's just to make it a bit easy rather than difficult. Let's say this is withdraw. Now, can these be valid entries? What do you think? The answer is yes. A person can withdraw $100. Like two transactions can happen in a minute. Correct? You will say yes, this is possible. It's not repeating. It's not a duplicated data. Correct, everyone? But what if I say 12 like seconds also? Now, does this become a duplicated data or a valid data? Means when I was not having seconds, it is a valid data. There can be two entries in a minute. Correct? Possible. But what if even seconds are there? Now, does this become duplicated data or it is still valid data? What do you think? It becomes duplicate, correct? Because it's not possible to withdraw by same person from a ATM like ATM withdraw. Just to make it more clear, in a single second, $200 separately, of course, separate transactions. This is a transaction level data. So this is duplicate, correct? Means the definition of duplicate is as per your data. If your data, if, when I say as per your data, means if your data is in this case, let's say having a valid data, if it is a minute data, this can be valid entries. But if your data is even at a second level, in that case, this data becomes a duplicate data. Okay, for a person A only, Okay, so just to mention that also, in fact, so it becomes duplicated data. Now the question is that how do we handle a duplicated data? So this is a duplicate. What do we do? Usually we tend to drop the duplicates. Okay, because that entry is already present. Why would I want to keep exactly same copy of that row? Could have been generated due to some error or some XYZ while things while generating the data. That could be the reason. Okay, but how we tend to drop the duplicate data. Now, before dropping, first of all, you'll have to figure out what are duplicated data. Correct. So df, if I want to check df for duplicated rows, so simply df dot duplicated, and it returns you a series where the whole row is first of all looked, and if it is a duplicate, then it is then you will get a true, else false. You can also do a dot sum on top of it. For example, if I say df duplicated dot sum, so it will tell you that how many rows are duplicated. So it says one row. Now I have a question for all of you. When you talk about duplicates, so let's say 1, 2, 3, 1, 2, 5, 6. In this, which entries are duplicates? So you'll agree with me this one, correct? Because already they were present and then they have come up again, correct? Does everyone agree? Please focus everyone in the, if because after this the concept will come and then everyone will start stating that why this, why that, correct? Because they are coming up again. But there were data points. So early data points, I'll say early, and this is data. These are duplicates basically. So these are the first entries, first, and then these are the second entries basically, which we say or last entries or duplicates, whatever you want to call them. So same is the logic with pandas as well. But you can alter the logic. If you want to see that I'll call first values a duplicate and not the last values, that can also happen. So pandas allows you to play with that logic completely. So how do we do that? For example, if I say dot duplicated, and I put this inside the indexing part and I run it, so it will show me wherever it was true, only that row is shown. So it says that okay, row number 124 is completely a duplicate. Okay, but now your question would be, so when is the first row present? Correct? When is the first row present? You would want to talk about that. So for you to see that, because I would want to get that. How would I do? So we are saying that if a occurrence is happening every time, for example, if I'm saying 1, 2, 1, 1, 1, so all these rows all will be marked as duplicate. So when I say keep is equal to false, keep is equal to false means, all occurrence is equal to duplicates. Okay, all occurrences are equal to duplicate. So I'm saying df dot duplicated keep is equal to false dot sum. Now it says two rows. Why two rows? Because first it was like 1 2 1, only this was mentioned as duplicate. But now I said keep is equal to false, so both rows are duplicates. Hence the count from 1 goes to 2. And when I say df dot duplicated keep is equal to false, and I do this over here, you see it shows me both the rows which are exactly similar. Okay, initially only 124th row was shown over here, correct? But now 123rd row as well as 124th row, both rows, both the occurrences are shown as duplicates. Clear to everyone? So that is a way where you can see all the occurrences are duplicate. Now your question would be that does it check for the whole row? If the whole row is duplicated, then only it says the duplicate. The answer is yes. Okay. The answer is yes. But now your question would be, what if I simply say that I want to only look in particular columns? Can I do that? The answer is yes. For example, you can say subset gender and smoker. For gender and smoker, get me the duplicates. Now can you tell why it is showing the number of duplicates as 240 when I'm simply looking the number of duplicates with respect to gender and smoker column only? Can anyone tell? Think about it and tell me. Use your brain. See, there are only four possible combinations that will be unique in gender and smoker, correct? Male, yes, male, no. Female, yes, female, no. Rest everything will be simply occurrence again and again and again. That's why only four rows are valid and 240 rows are by default termed as duplicates. What if I say keep is equal to false in this case? Then everything will be termed as a duplicate, hence 244 will come as a count. Now, how to drop duplicates? By using the function drop underscore duplicates. Keep is equal to first means that keep only the first occurrences. Any occurrences that are happening again, simply drop them. That is what this function is telling over here. Okay. And in place true, that make the changes to the data frame itself. Hence, now we are only having 243 rows and 8 columns. 243 rows and 8 columns. Questions, anyone? Then in that case, instead of keep is equal to first, you'll say keep is equal to last. Toby. Okay. Okay. Now, how do we transpose the data frame? Like making all the rows as columns and all the columns as rows by simply using dot capital T, like how it was in NumPy. So df dot capital T, all the rows becomes columns and all the columns becomes rows. As simple as that. Okay. Now, and does it change your data frame originally? The answer is no. Your data frame is still the same. Okay, no changes happens to the data frame. Now we'll talk about one hot encoding. Okay, and before this, now let's talk about the type of data. So I'll tell you what one hot encoding is and why do we tend to do it. And before that, of course, you'll have to talk about the data and its types and all those things. Now, pd.getDummies converts your data into one hot encoding. Don't worry, we'll talk about it. But what one hot encoding is, if we say data is equal to df and you say columns is equal to, you're passing the column that you want to do, one hot encoding on top of. Means I'm doing one hot encoding transformation on the day column. So what happens if you look here, all the unique values of the day column are made as columns, and if that value was present, it is termed as false. Else, and if that value is present, it is termed as true. Else, it is termed as all the other values are termed as false. So if you see in first column, it was Sunday. So for Sunday only, it will be true. For example, as you can see, and everything is false. So what we are doing, we are expanding the column. We take the day column, all the unique values of this column becomes the column in itself. And what happens is that where what entry was present, only that column, this term column is made as true, and rest everything is false. We call this as one hot encoding. So we are doing one hot encoding transformation on top of the day column. Now, why do we do it? Because by default, please listen carefully because now you have seen the whole. We also talked about the whole life cycle of the data science project. Why do we do it? Because your machine learning models, they cannot consume string values directly. They cannot consume string values directly. So wherever you are having string values, we tend to convert into one hot encoding. Now the question would be, do we always use one hot encoding? The answer is no. There are many types of uh, encoding that are present or transformations, and that is what we'll be talking about now. First, we'll talk about the types of data, and then when to use label encoding, when to use one hot encoding, and various other transformation, numerical transformation. We'll talk about that now. But yes, but the sole intent is that machine learning algorithms tend to work only on top of numbers. They cannot directly work on string values or values which are not numbers. So we have to convert these values to numbers. Now, if the data is categorical, what is categorical data? Most of you might know, but those who do not know, don't worry, I'll take that up. We tend to convert that to one hot encoding or label encoding or some other thing. So far, clear everyone? Any questions? Yes, Sudhir, correct. Okay, so now let's do one thing. Let's start going through the types of data, and then is when it will make sense for you to understand this thing in much more detail. But I hope till this point, no other questions are there. Now let's jump into the things. But yes, any questions, please put in. Using the backend code, Boolean is okay. So what does the first row contain? For day column, what is the entry? Sunday, correct? To be. So what happens is all the values, all the unique values become columns. Now it was Sunday. For Sunday, it is true for the first row. Rest everything is false. Able to see? Same way, what was the second value? Again Sunday. So for second row, only the day Sunday column is true. All everything is false. Now what was the third entry? Third entry was Saturday. So for only day Saturday it is true, and rest everything is false. Indicating that okay, this is so we call this one hot encoding. Why do we do it? Because machine learning models cannot directly consume string values. They do not know what that is. So now your question would be then why cannot we say Sunday is equal to 1, Saturday is equal to 2, Monday is equal to 3, and Tuesday is equal to 4? Correct? That could be a very valid question. We call that first of all as label encoding. Means, just to repeat, you are saying that, okay, Rahul, you're doing one hot encoding down here. But why can I not simply say Sunday is equal to 1, Saturday is equal to 2, and let's say Friday is equal to 3, and uh, let's say Thursday is equal to 4? Why can I not do this? First of all, when you're assigning values like this, we call that as label encoding. Okay. Now, why we cannot do in this particular case? Because just to give you an example, of course, it can be done in this case, but I'll give you that context. But why we cannot do? So, can I say 4 is greater than 1? Can that be said? What do you think? I can say that in terms of numerical, in terms of numbers, 4 is greater than 1. But is Thursday greater than Sunday? Like, are they comparable? What do you think? Are they comparable? The answer is no. But when the number goes into my machine learning model, it will say, okay, 4 is greater than 1. It will try to learn the pattern in this way. But really, in real sense, in real world, they are not comparable. Okay. So hence we do not do label encoding. We tend to do one hot encoding. Don't worry, we'll look into the data and its type uh, now, and you'll be able to understand when to do label encoding, when to do one hot encoding. Don't worry on that part. But yes, any questions? Please put in your questions. Okay, so now let's move to the blackboard and let's start to understand the data and its type, and when do we do one hot encoding, when do we do label encoding, when do we do some other types of transformations. We'll talk about those. So stopping the share, moving to the blackboard. Just give me a second. So I hope my screen is visible to now, everyone. So there was some delay in the application working properly, but yes. Okay. Now see, we'll talk about data in this case today. So data. Now, data can be classified on multiple bases. And anything, in fact, not only data, anything that you would want to classify can be classified onto multiple things. For example, in case if I want to divide the class into certain codes, I can first of all use gender, male, females, two groups will be made, correct? I can use another thing for dividing, for example, experienced in IT or having some experience in another field or completely beginner. So three groups will be made, correct? I can use based on region that okay, with which country are you present currently taking the class from. So again, multiple groups will be based. So you can classify anything based on multiple parameters, correct? Based on multiple things. Same way, you can classify anything on numerous logics. Classify it onto numerous logics. For example, data can be classified based on structure. It can be classified based on type, format like PDF files, JPG files, uh, okay, and many more things like what is a source, Excel files, or like IoT data, internet data, XYZ things like what's the source. So same way, data can be divided into multiple things. So first, just to go through the structure, that is what plays relevance many times. For example, basis on structure, data is divided into three parts. Basis on structure, data is divided into three parts. What are those three parts? Those three are structured, structured data, unstructured data, and semi-structured data. Correct? Now the question would be what is structured data? Which is organized, it is searchable easily, anything can be searched of course, but yes, it has rows and column structure. Rows and columns. Example, your spreadsheets, correct? Excel spreadsheets, CSV files, databases, correct? All these fall under structured data. What is unstructured data? Lacks organization, difficult to filter, okay? For example, text data, images, videos, all these fall under unstructured data. Okay, it's okay. Semi-structured data. Semi-structured data is structure that is partially data that is partially organized. Data that is partially organized. It contains tags basically, like contains tags or labels to separate elements. For example, JSON files, which acts like JSON files, XML files, HTML files. Okay, so all these fall under semi-structured data. Okay, now same way, basis on structure, this is how the data is divided. Now, basis on values or type, data is divided into other parts. So, basis on value or type, data is divided into two parts. So, what are those two parts? Qualitative data people also call this as categorical data. And quantitative data. Quantitative data. Okay. Now, this is further divided into many parts, but we will do that. But any questions till this point based on structure? And based on structure, this is how the data is divided. Based on values and type, it is divided into two parts: categorical data or quantitative data. What is categorical data? Let's deep dive into this now. This is basically non-numerical data. Non-numerical and is descriptive, like it describes. Example, like color, black, white, blue. Okay, and it keeps on going, of course. Customer types, or let's say reviews, just to make it in that way. So reviews, good, best, normal. Okay. So in plain sense, this data will answer you like what kind of data, what is the kind, what kind. So good, uh, or how, like how did you do, how was the food, great. So these kind of questions you will answer. What kind or how, basically. What day? Sunday. How was it? Good. So these kind of information it tends to deliver. Now it is further divided into many parts. We'll talk about those now. It is divided into many parts. The first one is nominal data. Now, what is nominal data? Nominal data is, in this kind of data, there is no order or ranking. Like you cannot rank this data. First of all, have you got the understanding? For example, in our day, in our information, day is example. Another example. If I put it over here, day is as well as also example of this, like Sunday, Monday, Tuesday, Wednesday. So these are also example of this kind of data, where the data is categorical. It's not numerical, which I've already written non-numerical data. Okay. So in this, it's further divided into nominal, no order or ranking. For example, like you cannot rank blood group. So blood groups are A, B, A, B, O, correct? You cannot rank them that this is good, this is bad. Okay. Another example could be gender. Okay. So this is usually present in your column. For example, blood group, and you might have among many columns this kind of information like O, A, B. And in this case is when you apply one hot encoding, one hot encoding. When the data cannot be ordered or ranked. Getting it? So in this case is when you apply the one hot encoding by simply saying A, B, AB, and O. And then simply saying 101, sorry, 100 or 0010. Like these are indicating true and false basically. Does it make sense? Now, where in this case is when you are doing one hot encoding? Okay. Then there is another kind of data. In this case only in qualitative data. The second type is ordinal data. So first one we talked about nominal. Now we have, sorry, ordinal data. What is ordinal data? So it has order or ranking. Has order or ranking. Okay. But but interval between categories is present. Sorry, is not specified. Interval between categories is not specified. I'll talk about what I'm trying to say. Are not specified. Just to give you an example, in education, let's say education you're having. In education, I can rank the data. Like, for example, I can say high school. Then my second, like, and again, try to think of this as a column, like you're having an education column, okay, and in which these entries are present. Try to think it in that particular manner. Okay, high school is there. Then you have, let's say, bachelor's, correct? Let's say in that case, sorry, let me change the color. You have bachelor's, then you have master's, and you have PhD. Like and many more informations can be there. But can they be ranked? Like, can I rank them at high school with value 1, for example, bachelor's with 2, Masters with 3, PhD with 4. Can I rank them? First question. Correct? So even if the data is not in numbers, it can still be ranked. Correct? It can still be ranked. Another example. So this is what is ordinal data. Just to give another example. For example, ratings. So you might say neutral, good, and bad. Correct? So you might see that, okay, for bad, I'll simply say 0. For this, I'll say 1. Or I'll say -1 for this. For this, I'll say 0. And for this, I'll say 1. Correct? It's up to you, whatever numbers you are giving. But what I'm trying to say is that this data can be ordered. This data can be ordered. So this is where we tend to do label encoding. This is where label encoding is used. Label encoding is used in this case. What is label encoding? That I simply put in labels over here. Like I'll say this is 1, this is 2, 3, 4. And I can now in this case say over here that 4 is greater than 3, is greater than 2, is greater than 1. Okay, so this is what we call as label encoding. Now please try to understand this particular part. So you might say that, okay, you mentioned specifically that for ordinal data, interval between categories is not specified. What do you mean by that? What I mean by that is that even if this data can be ranked, can you specify some difference, like a constant difference between them? That, okay, bachelor's minus high school, so can be similar to PhD and masters. You cannot say that, correct? Because every duration is different, every amount of time and what you are studying is different. They can be ranked, but you do not know what is the difference in numbers between bachelor's and high school. Getting it? So there are no specified intervals between these data points. Does it make sense? Hence, interval between categories are not specified. Clear to everyone? And now we'll just talk about the last one and then we'll go for a break, and post the break we'll continue then. Just give a second, just the last one, because I don't want to leave this in between. The last one in this kind of data is what we call as dichotomous data or the binary data. I think I'm using okay, red color. So I'll use the same color. We also call this as binary data. Okay. Only two possible values are there in this kind of data. Only two possible values. And let me underline this. So only two possible values. Example, yes / no, pass / fail, present / absent. Okay. Now you might ask, so what kind of transformation would I do on this data? The answer is you'll simply label them as 1 and 0. Simply. Correct? 1 and 0 or 1 and 2, whatever you want to label them, because there are only two possible values, for simply true or false. Getting it? So that is the kind of transformation that essentially happens, because this is a minimum number of values that would be possible. If a column has always one value, so it's not at all helpful. So you do not need that column. Okay. So in dichotomous data or binary data, we tend to only keep 1 and 0. If you are having yes, no, or pass, fail, we simply tend to use 1 and 0. Clear to everyone? So just to give you a revision, we talked about data on terms of structure is divided into three: structured, unstructured, semi-structured. And then based on value, qualitative data and quantitative data. We'll talk about quantitative after the break. But in qualitative data, it's a non-numerical data, it's descriptive basically. Okay, we talked about examples like good, best, reviews, or day, or color, gender. Okay, so all these fall blood group, all these falls under qualitative data. So nominal data, no order, no ranking, like blood group or gender. Ordinal data, which can be ranked, for example, education or ratings. Okay, dichotomous, which it's simply having two possible values. We call it as a binary data. We'll continue with the qualitative data after the break. But let me pause over here and let me first of all launch the pool. And in case if you have any questions, meanwhile, please post in the chat. Any questions, anyone? Please post in the chat. While working on any system means, so basically, I think you're referring to data science, correct? In data science or machine learning models, what we tend to use. So what we are studying currently, the values and type one, whether the data is qualitative or quantitative, whether it's nominal, ordinal, continuous. So this only, that's why I'm teaching this only, in fact. And of course, semi-structured or structured is also used. So I put in that information as well. Okay. Okay. So I'm ending the pool. Let me share the screen with the timer. Let's go for a break. And after the break, we'll continue. So just give me a second. So I hope my screen is visible to everyone with the timer. Lakshmi, the class is ongoing. We just discussed the data and stopped the sharing. Now, then I conducted the poll. Now we are going for a break. Class is ongoing. I'm not sure what is happening at that end. Okay. Okay. So let's go for a break. See you after the break, everyone. Thank you. Is everyone back? Yes, Lakshmi, the screen with the timer was shared. So you're on a break. Yes. Okay, so let me share the screen again and let's continue with where we left off, talking about the quantitative data. Okay, just give me a second. Let me share the screen. So I hope my screen is visible to everyone. Okay, so we talked about the qualitative data in which like what that data is. It's basically a non-numerical data, and it is divided into nominal, ordinal, and dichotomous or binary data. And now we'll be talking further on quantitative data. Okay, so now quantitative data is opposite to what we were going through here. So let's talk about that now. So it is first of all numerical in nature. It's numerical and is measurable. Okay, it's not descriptive. You can measure this data. So okay, for example, it has quantities or amount. Some examples of this could be income. It can be any number, correct? It can be any number. Height. These are completely any number can occur over here. Weight, sales, etc. and etc. Many more things will come. So this is what quantitative data is. For example, in our case, total bill, tip. Okay, these are quantitative data, which are numerical. Size is also that, but again, it can be said as a discrete data. We'll talk about that. Now, quantitative data is also further divided into two parts: descriptive data and continuous data. Sorry, discrete data and continuous data. So if I try to kind of divide it further, so the first one is discrete data. Now, what is discrete data? It is basically, it consists of countable and separable values. Countable and separable values. Okay. They are often denoted as a whole number. Often denoted as a whole number. Okay. Example: number of students in a class. For example, and this, of course, you will have multiple numbers, but can it be in decimals like 33.2, 35.6? Can it be in that shape? Number of test questions in paper. So all these fall under discrete data. Same, our size column in fact is also discrete data. It is numerical. Again, just to mention, it is a quantitative data which are numerical and are measurable. Okay, but when it can be only in whole number, then is when we say it is a discrete data. But again, it's simply a still a numerical data. Okay, then the second one is the continuous data. Continuous data. Now, what is continuous data? Now, this data can take any range, any value in a given range. Now, your range can be, of course, from minus infinity to infinity. Okay, it can be from 0 to 1, it can be from minus 1 to 1. It can take any value inside that range. From example, range can be from minus infinity to positive infinity. It can be 0 to 1, and the values that can occur in between can be still a lot, correct? Can be still be infinite. Getting it? Do you agree with me on that? Okay. Hence, we can say that this data can be measured. So I can say that this data can be measured to any level, can be measured to any level of precision. Any level of precision. Okay. Example, just to give you example, height, it can be 1.72 meters, or to further move, it can be 1.728395643821. It can go till any precision. Getting it? Is it making sense or not, everyone? Time taken, 10 seconds, or again 10.20 seconds, or further moving 10.20895622, any number basically, that much seconds. So that is what is a continuous data. Now your models can easily work with quantitative data because these are already numbers, integers. Okay, but models need certain transformations on qualitative data, which can be nominal and ordinal, and sometimes dichotomous as well. So this is the play around data I wanted to talk about. Yes, Lakshmi, the class has started. Just give me a second. Lakshmi is not able to hear or see anything. Let me text her. Okay, so I hope everyone is able to hear me and everyone is able to see the screen as well, correct? It's not, uh, okay, perfect. Okay, so this is what I wanted to talk about data. And usually the transformations to convert data into other values is done on the qualitative data, not on the quantitative data. Okay, so nominal, ordinal, they tend to undergo transformations, whereas for discrete, the data transformations do not happen, where we simply are converting data to some buckets. That those are different things, but these kind of transformations like one hot encoding or label encoding we do not tend to do. We tend to do scaling or bucketing or binning for these kind of data. What is binning? For example, I say 0 to 10 as a lower bucket, 10 to 20 as a middle bucket, and 20 to 30 as higher bucket. Okay, so any values between 0 to 10 will be always belonging to the lower bucket. Okay, so I'm simply converting or making some intervals with respect to the data. So questions, anyone? So I hope everyone is clear till this point. So that's good. So now so I hope everyone is able to understand one hot encoding is, as I explained over here. Okay, so 100 we have seen over there. So this is a part that you can simply do using pandas. That's why we moved from pandas to over here, just to understand the types of data, because then when it makes sense to understand when to apply what type of transformation as well. Okay, so moving back to pandas, but yes, in case if we have any questions, please put in the chat. Stopping the share, sharing the pandas code, panda screen now, and we'll be going through in detail. But yes, any questions, please put in the chat. So is my screen visible to everyone? Okay. So we talked about one hot encoding now. So now this makes sense to you how I can insert, and again, false is simply 0 and true is simply 1. So we are able to convert this categorical data into some discrete data, okay, data that can be represented using numbers. So this is what is one hot encoding. Okay, now I have a question for you. Just think about it. When I'm converting a column to one hot encoding, like in our case, we are converting the day column. So all the unique values of day column have gone over here, and we are getting those values. And so what happens? Or if there are n values, so there are n columns, correct? Now my question to you is, can I still get all the information if I simply use n minus 1 columns? Means instead of 4 columns, if I simply remove this column, can I still tell when it was Thursday? What do you think? If I do not populate the Thursday column at all, can I still tell when it was Thursday? Correct. So I can still tell it. Okay. So usually this column still can be deleted because all the information of Thursday can be still captured if everything is false. Okay. So it would be a Thursday. You are correct. Hence, you'll see that when people are doing one hot encoding, they tend to drop one of the column. How? By simply using the argument drop underscore first is equal to true. Why? Because just the 3 columns are capable of giving the information about the 4th column as well, like whether it's a Thursday or not. If all 3 are false, so yes. So you tend to say drop first is equal to true. So your first unique value is dropped in that case. Okay. So that is what happens. So any questions, anyone till this point? I hope everyone is clear. Now let's move ahead. Now we'll talk about group bys and data analysis part basically. Using pandas, you can get good summaries about your data in quick goes. Okay, so data aggregations and analysis is what group by and pivot tables will talk about now. Okay, so let's move ahead. Now, what if I say I want to group my data based on gender and time? When I say group means dividing the data based on gender followed by time. Means first I'll divide the data based on male and female, and then inside male I'll divide it with respect to time. Same way inside female data I'll divide it with respect to time. Okay, so I'm simply grouping the data based on gender followed by time. Okay, I can do that, correct? Why would I do that? So that I have separate data, and if I want to do certain analysis for the females specifically on Saturday, I can do that. Like what is the average bill and all those kind of informations, I can do that. Okay, and that is the intent over here using group by, so that you can do analysis at much more granular level as well. And of course, you can do at the whole data level also. Totally up to you. So what I'm saying, so how do we do that? How do we make groups in pandas? We make groups in pandas using the group by function. Using the group by function. How? So df dot group by gender and time. Now, first of all, we'll try to understand how this works and all the things around it, and then we'll go into much detail. So df dot group by gender and time. So you're saying I want to group my data based on gender followed by time. Once you run this, so it shows you this certain like this. So it tells you that this is a generator. Means essentially it will only give you data once you ping it once required. Otherwise, it simply takes in a space and sits and it does execution one only when it is required. So I'm saying grouped is equal to df.group by, and I'm simply having the same thing. Like I simply stored it into a variable. Now there are certain functions that you can do with this grouped variable now. Okay, a lot of things you can do with this. But just to work ahead, if I say grouped dot groups, can you see female dinner over here? See closely what is happening. Now all the groups that can come up with gender and time column from my data will be present over here. Meal and dinner, meal and lunch, okay, female and uh, lunch. Do you see this? Now your question would be then what are these numbers indicating? These numbers are indicating the index of rows. It says that for female and dinner, 1, 2, 5, 7, 9, 15, 20, like these are the indexes of the rows that are belonging to this group. Okay. And if we simply say grouped, like this particular variable only, dot groups, which is this particular part, dot keys, which is because it's if you look closely, this is simply a dictionary. Okay, dot keys, it will tell you that female dinner, female lunch, male dinner, and male lunch. These are the four combinations based on doing grouping between using gender and time from your data. From your data. Okay. So it tells you that these are the combinations, and you have, of course, all the indexes of these rows as well, which belong to which particular group. It is a dictionary. Now your question would be, how can I get group? For example, if you simply say grouped dot get underscore group, female and dinner, so it only returns you the data which is for female and dinner. Now your question would be, I can do this whole filtering by myself, in fact, correct? Like you can simply say df square bracket where gender is equal to female and time is equal to dinner, correct? Yes, you can do that exactly. Correct. But the thing is, here you are simply running this and you're getting all the possible combinations of gender and time column as a group itself. So that gives you much more convenience. Okay. So that is what happens over here. Now moving ahead. So just to mention, can I do this like this? Yes. And just to show exactly same number of entries will be present. So 1257. Okay, and now here also if you say uh, 1257 and again 52 rows only. Okay, so it's one and the same thing, just a much more holistic view where it allows you to simply get all the groups with respect to certain columns from your data. Now you might think that okay, we got a group, we can use this. Yes, are there any other use cases? Yes, there are other use cases as well that can help you to simply do certain aggregations and get some descriptive information on top of these groups. For example, if I say df.group by gender and time, and I'm saying give me the average, that is a mean, and numeric only means that it will only do for the columns which are numeric in nature, Once I run this, you can see that when it was female, the person was female, the time was dinner, the average, because I'm using mean aggregation, the average total bill was 19.21. Average tip was 3.00. Okay. Now I can compare also, in fact. So I can say usually when the person is male, time is dinner, the average bill is highest compared to all. Okay. And when it is female and lunch, the amount is the lowest. Okay. Who pays the highest tip? When the person is male, dinner. So the person will usually, that is when we get the average, like the tip is usually highest. When I say usually, because it corresponds to the average part now. Does it make sense to everyone? What is happening over here? Okay. Now your question would be, can I do n level of group bys like using multiple columns? Yes, you can do that. For example, df dot group by gender, time, day, and I want an average. Okay, and I'm simply rounding it off to 2 because there are multiple decimals otherwise. So when I run this, so when the person is female, time is dinner. On Thursday, average total bill is 18.78. When the person is male, is on dinner, the day is Saturday, average bill is 20.80. Do you see this? So much more granular information now. So quick descriptive information. Okay. Okay. Now your question would be that, okay, I do not want to have a look at mean. Are there other aggregations possible? Yes, there are a lot of aggregations that are possible from sum, come sum, uh, mean, median. So all those aggregations are possible in fact, along followed by count and many more. So df dot group by, I'm saying group by what? Day and time now. So day followed by time. Sum, that I want to do a sum. And of course, this is numeric only. Just keep that in mind. Numeric, like I only want to do for numeric only columns. Okay, so that is what this argument is stating over here. So it says that given when it was Friday, time was dinner. So the total bill, like total amount collected, was 235.96. When it was Sunday and dinner, 1627. When it was Saturday and dinner, 1778. Of course, the sum with respect to this column does not make sense. So you can drop it also, and again we can do multiple aggregations. So we'll see that, like whichever only you would want to do, we can do that. Okay, so the highest number of people come on Saturday dinner, and that is where we get the highest amount of bill as well as tip also. In fact, if you look across the data, okay, and followed by Saturday dinner. Now your question would be that, okay, can I do multiple aggregations on a column in a single go? The answer is yes. How? So df dot group by gender and time. Then you are saying dot ag. So this stands for the aggregation function. Dot ag. Inside this, you pass in a dictionary. Okay, a dictionary in which keys are your column names. Keys are your column names, and the values are list of the functions that you would want for that particular column. So for total bill, I want sum, minimum, maximum, count, mean. For size, I simply want to have sum. For tip column, I want to have mean, minimum, and maximum. Now once I run this, you can see that for female, when it was dinner, for total bill, the total bill that was collected when it was female and dinner, 999. Minimum amount 3.07. Maximum amount 44.3. Count 52. So 52 entries for this. Average bill 19.21. Do you see how quick we are able to get so many analysis and so much information in a single go? Questions, everyone, please. Any questions? And of course, can you might say that, can I select simply the columns after doing the aggregation? The answer is yes. For example, you're saying df.group by on gender, day, smoker, give me the average, and I only want to keep these two columns, total bill and tip. Now once you run this, so it, like if I simply comment this out, it will give me for all the numeric columns. It could be that you might have a lot of numeric columns in your data, but let's say you only want to select two, you can do that using this also. But this is not recommended. Rather, you would use this. That's a better approach. Like only select the columns for which you want aggregation. Otherwise, if you do this, first aggregation is calculated for every column, then you're only selecting two columns on top of it. So it takes a bit more on time. So questions, anyone? Now your question would be, can I do my own aggregations? Yes, you can do your own aggregations. Okay, you can write a whole function which can do certain aggregation, return as an output. So I'm simply writing a lambda function. Again, a lambda function is simply a single line function that you can put in. But in case if you want to write a function which goes 500,000 lines, you can do that. What I'm trying to simply state, anything is possible. Just the aggregation needs to be done. For example, I am here saying that df dot group by on what? Gender and time. Okay. What aggregation do you want? I want to use my own aggregation, so I'm saying dot egg. So I'm saying lambda x and return a set of x. So all the unique values are returned over here. So my own function, once I run this, so it says that when it is female, it is dinner. So these are all the unique values for total bill. These are all the unique values for tip. These are all the unique values for a smoker. These are all the unique values for day. Does it make sense? What is happening? So whatever aggregation you would want to do, you can do. I'm just giving you an example, of course. Okay. And it does not change your data at all, just to show you. Your data is still the same. Now, one problem that you might face a lot is that, okay, once you are doing the aggregations, because now it is sum or minimum, so you would want to rename your columns because someone might think as a total bill, but why would want to rename these columns directly? Means first you'll do this and then you might rename it. But is there any way using which you can directly rename the columns in this code itself? Like you get the column names as what you want to be. Yes. Okay. We call them as named tuples. So what you're doing? Simply saying df.group by. Okay. Group by on what? Gender, smoker, day, time. Okay. Now instead of passing in a dictionary, you can pass it in this fashion as well. We call these as name tuples. You are saying that I want to make a column, total bill sum. Okay. So it will say that, okay, in which column and what you would want to do. I'm saying for total bill column, I want to do sum. And I'm saying total bill mean column. So total bill column, I want to do a mean. So this is how you number of entries. So total bill column, and I want to do a count. So once you run this, so it tells you a lot of information. So it says when the person is female, is not a smoker, the day is Friday, and it is lunch. So the total bill received 15.98, average bill 15.98. Any standard deviation because it is one entry only, so no standard deviation. Okay, number of entries one, only one entry is there. For example, I have 13 entries over here. So female no, Saturday dinner. So total bill sum 247. Total bill mean 19.00. Total bill standard deviation 6.73. From average, this is how much the deviation is usually. That is what it tries to say. Number of entries 13. And do you see how the column names are what I want them to be now? Questions anyone so far? Please put in your questions. If no questions, please write clear so that I understand everyone is clear. Okay, perfect. Now, see if you like this is my new group DF in which I have these four columns. Now, please understand that all these four columns are indexed now. Means instead of us having a single index in our data like we used to have, like these index that we used to have 102, after doing a group by, like all these column values become your index. Like these are my index now. Okay, all these are my index now. Okay. Now the question comes that, okay, how do I extract or work with the data? Like if we now if you see new group df dot index, this is how the index looks, and this is what we call as a multi-index. This is what is known as a multi-index. Okay. Now you might say that, okay, how do I extract data for a particular index? For example, I want to extract for female and no. Like I only want to keep these filters and extract all this corresponding data for female and no. Can I do that? Yes. How? Simply using dot lock. So you can say new group df dot lock, and you can say female and no for female and no, and all the data for female and no is shown over here. Same way, you can do n level of indexing. You can say female no and Saturday, so it will only show you for Saturday as well. Okay, so all those things can be done easily by using lock. Again, your new group df still remains the same. Now there is one unique level of indexing as well that you can do. Okay, so instead of dot lock, you can use dot xs as well for doing the indexing on a multi-index. For doing indexing on a multi-index. How? You can see that I want mail and Friday. Now see, this allows you in a unique fashion. Means, just look closely, please everyone. This is important. Otherwise, you'll keep on asking questions on this. You'll not be able to understand this. So please pay attention. Now, when you're using lock, you can query the data as well. But this is a new technique, .xx. Now what you are saying, I want mail and the data for Friday. So mail and Friday, like I'm not including the middle index. So you can pass in any index that you would want, mail Friday, but you also need to specify the level, that what is the level for this. Usually, because we are having 4 columns, so in that index starts from 0. So 0 index, first index, second index, third index. So you are saying mail belongs to the 0th index and Friday belongs to the second index. Does it make sense? What is happening? So you're saying new group.df .xx, I want to extract the data for mail and Friday, which are these values. For level, mail at 0 level, Friday at second level. We need to specify that. And then there is argument drop level is equal to true, means do not show me these indexes now, because I already know I have extracted mail and Friday. So I already know that I'll get the data for this. But if there are any other index like no and dinner, show me that. So drop level true means drop the indexes which I'm asking you to show. So like if I run this, you can see only smoker and time index is shown now. Okay, only smoker and time is shown now. And in case if I say this is false, so all the index will be shown. Do you see gender, smoker, day and time? So does it make sense to everyone? Same way you can say male and no and specify level, drop index true or false. You can do all these things. And your data still remains the same exactly. So any questions anyone, please put in the chat. Any questions anyone? Any part that you have not got, please put in the chat. Using the group bys, on group bys basically. This part, Toby, do you remember sets that we studied in Python class? Set. Do you remember the lambda function, how the lambda works? So what we are doing over here, we are saying that for gender and time column, I want to take all the values for every column, total bill column, tip, smoker, and get the set out of it. Okay, so which part to be? Okay, 0, 1 and 0, 2 dot access part. Correct, I got it. So see, now there are 4 indexes 0, 1, 2, 3. Now I have simply said that I want for mail and Friday. But how does Python know that mail is present at which index? Like which index are you looking for? Should I look in third index for mail or should I look in second index for mail? In which index should I look? So that is what we are saying, that mail you should look in 0th index, Friday you should look in the second index. Getting it? Now, Toby. What about others? Any questions, please put in which questions, any part that you have not understood, anything, please. Is it getting too complex? Mm. But yes, of course, things will start getting complex now because we'll have to start deep diving into the data science field now. So doing analysis on top of data. So this is what we do analysis. For example, what is average, mean, how many counts, and of course, when we go to machine learning, we'll start learning mathematics and so many things. So as things will start getting a bit uh, amazing as well as complex as well. But yes, I'm trying to keep it layered, starting from the basics all the way to advanced. I do not think it should be confusing, honestly. I can understand that it is difficult to absorb at first go, but it can be complex as well to understand. But uh, I, I particularly think it would not be confusing like what is happening, because we know, okay, for gender, smoker, daytime, we are getting her total bill sum and those things. So we are getting our average and those things. But yes, and just to repeat, please everyone, during the week, please go through the recordings, please revise, please practice. Otherwise, ultimately, things will start getting much more out of hand. In case if you're thinking that, okay, they are already out of hand, they'll start getting more out of hand. We'll have to move quickly and get all the things back in line. And how will you do that? By self learning, by doing revision during the week. So you have 5 days in between, during which you can, even if you take out 3 to 4 hours at every day, you'll be able to catch everything up and you'll be able to prepare yourself. Because of course, no one is able to learn things on the first go. Even if I'm showing you a code, can you learn it in one go? The answer is no. Okay, so you'll have to be very good with Python, very good with libraries, then only can you might learn it in one go. But otherwise, no one is able to do that. So it requires revision. That's why I do not tend to give homeworks, because you already have so many things for all of us, for all of you to learn and go through. I do understand, Toby. That is the case with everyone, honestly. In fact, in with me as well. But yes, and that is how you try to manage multiple things. That is how you learn new things. But yes, so any questions, anyone? Please put in. So now let me do one thing. Till pivot table, let me share the code, because we have covered these group bys and they of course require your absorption, how they are working, what they are doing. Because it could be I might have just shown and moved. But again, it would make much more sense if you go through this. So let me share the code again in the chat along with the data. Please, till pivot table, try to go through it, try to play around with it, try to change the columns and see what is happening, try to change the aggregations and see what is happening. That will help you to get much more clarity about what group by is essentially doing. Okay, and when you will be changing this, you will be of course learning the syntax. You'll see, you'll read it. Okay, df.group by, let me do it for smoker column. So you'll be able to understand that how things are working. So I've shared the code and the data in chat. Request you to please go through the whole code from starting till the pivot table. Why I'm saying from starting? Because if you are going through the same thing again and again, ultimately that is how you remember things. Okay, so if you go from starting, so all the things which you are covering for third time, fourth time, you will be able to remember all those things, because you've already gone through them 3 times. Now it will be the fourth time, in fact. So please, from starting till pivot table, and this library is really important. So that is the intent of asking you to going through multiple things again and again, because it is a very commonly used library. So please go through this. Do let me know once you are done. Then we'll move ahead. Okay. Meanwhile, if you have any questions, please put in the chat. Any particular part you have not understood, put in the chat. Toby, the aggregation is still a set, no? Hence, that is the output. Because we are still getting the set as output. That's why. So a single thing should come as output. That is what we can call as aggregation. Yes. So has everyone gone through the code? Till pivot table. Any questions? Any doubts? We are mentioning the index, Krutik. So XX is similar to dot lock function basically for extracting the data. But dot XX only works with multi-index data, whereas lock can work with single index, multi-index, everything. No, Krutik. And what about others? Correct. So Krutik XX is and same is what we also do in lock as well, correct? In lock function, we are specifying the columns. I do agree what you are trying to say, but yes, in XX, we are using the values, correct? Oh, they are different, Bharat. Toby, if you remember, like deleting Thursday column, still we'll be able to inference that when is Thursday occurring, correct? In one hot encoding. So that is what that comment means. It is completely technical. There is no business scenario around it. It's simply when you want to extract the data based on the backend index, Bharat. Whereas lock is for the custom index that we have. We talked about this in fact. Okay. So anyone else? Any questions? So let's cover the pivot tables and then we'll stop for the day and we'll cover rest things tomorrow because otherwise it will be a lot of things for you to go through. So let me share the screen. Let's cover the pivot tables first and then we'll move ahead. Okay, is my screen visible to everyone? Okay. Now, using group by, what we were able to do? We were able to divide data into groups and do any kind of aggregation on top of it, correct? And we can even get the groups as well. Like you can simply get the groups also. You do not want to do an aggregation, totally fine. You can get simply the groups also. That is what group by allows you to do. But now pivot table allows you to directly get the aggregations completely. Okay. Now, my first question to all of you: how many of you have done group pivot tables in Excel? So this is completely similar to that. So just no issues in case if you have not, I'll be explaining this in detail. So how we are using group by over here? What we are doing is we are taking all the columns, doing certain aggregations on top of them, correct? Like for female, no, Friday lunch, these are the things. Same way, if female, yes, Friday dinner, these are the corresponding information. So the same information is done using pivot table. The difference is that pivot table output shape will be different. Means pivot table shape is like this, much more horizontal. However, for group wise, it's usually vertical. That is the first major difference. Otherwise, both will be giving you exact same thing. Now you might say, can I use group by instead of pivot table? The answer is completely yes. You can do that. But if you want to change how it looks, you might want to use pivot table, and it also depends upon everyone's personal preference as well. Group by can give you groups as well, but pivot table cannot give you groups. It simply gives you the aggregation only. Now let's see how it works. So you're saying df.pivot table, that you want to make a pivot table on df. Again, pivot table function is also used for getting the aggregations and doing analysis. Okay, now you're saying index is equal to time. So you're saying take the time column and make that as index. So all the unique values of the time column becomes the index. So in our data, we only have dinner and lunch, hence those becomes the index. Then you say columns is equal to day. So all the unique values of day column become the columns, as you can see. Saturday, Friday, Sunday. So all the unique values of day column becomes the column. Now you are saying that okay, for total bill, values is equal to total bill, that all these values that should pop up over here should be corresponding to the total bill. Okay, and then you are saying for total bill I want to do aggregation of sum. I want to do a sum. So now how to read this information? So it says when it was Friday, it was dinner, the total bill was 235.96. When it was when it was Sunday, it was dinner 1627. When it was Sunday, lunch none, because there were no entries on this. Now your question would be that okay, it makes sense. Can I do that same using group by? So the answer is yes. How? Df.group by time, day, aggregation, total bill, sum. Now just if you look closely, what is happening is exactly same values are popping up. For Friday dinner, 235.96, 235.96. Now the whole thing is that usually in a single go it is horizontal in pivot table, in group by it is much more vertical. Does it make sense? That's up to you which function you would want to use, which your use case specifies, which is easier for you to use and understand. That's totally your call. Okay, now your question would be that okay, can I use multiple columns in index, because I would want to have multiple columns like how we were having in group by. Can I do that? The answer is yes. Can I use multiple values as well, total bill, tip, and all those things? Yes, you can do that as well. How? For example, you are saying you are saying that df pivot table index gender and day. So all the unique values of gender followed by all the unique values of day column. So female Friday, Saturday, Sunday, Thursday, male Friday, Saturday, Sunday, Thursday. Then you're saying columns is equal to smoker. That smoker column unique values becomes the columns. And then you're saying values total bill and tip. That for total bill and tip, I want this information. Like for here, these numbers should be speaking about total bill and tip. So that is why you can see tip and total bill over here. And you are saying that I want average of them. Means in plain sense, so when it was female, Friday, so this is for tip, if you see, and this is for total bill with respect to the smoker column. So when it was female, Friday, tip column, and the person was smoker, so this is the total bill. Sorry, average total bill 2.68. Sorry, average tip. Let me repeat. When it was female, the day was Friday, the person was a smoker, so the average tip was 2.68. When it was female, it was Thursday, person was not a smoker, so average tip was 2.45. When it was male, Sunday, the person was a smoker, average total bill was 26.13. Now your question would be, can I do that using group by? The answer is yes, you can do that. How? By simply using df.group by gender day smoker dot mean. That's it. And you get all the information. But of course in a much more vertical manner. Now of course up to you which you feel as good or not. And of course you can move smoker over here as well in case if you want to. That because otherwise it will be no, yes, no, yes, no, yes for every column. So you can say that okay, I want to move it over here. Much more easy to look at. So that can be done. Okay, so up to you which you would want to use, but yes, both ultimately give you same number, same values. Can we add dynamically the values in pivot table? When you say dynamic values, what do you mean by that, Bharat? You can add data from server or cloud, but for then first you'll have to join all that data, then only you'll do a pivot table. Means what I'm trying to say is your question would be that can I load data from server or cloud in pandas? The answer is yes, you can do that. Okay, but will the values be dynamically updated? No, you'll have to run this whole function again after getting the whole data, concatenating it, then only. Is it possible to perform different aggregations? Yes, you can do that, Sudhir, correct. But then again, the code starts becoming more complex and complex for pivot. So another example, index, gender and smoker, column stay, values this. And once you do this, you get a single kind of information. So all these things are possible. So let's stop over here till the pivot table. So we have covered till pivot table, all the components of pandas. You already have the code because I shared it in the chat window with everyone. So you can go through that as well. In tomorrow's class, we'll complete pandas. We'll cover the remaining concepts as well for pandas library. And then we'll be moving to another library, the visualization library, matplotlib. How do we use it? Why do we use it? Followed by cbon, followed by a verbal description, or you can say a demo of like what it can do for bouquet and dash. And then we'll move to another mathematical concepts. So this is how we'll be moving ahead. But yes, tomorrow we'll try to complete pandas, and in fact, we'll be able to complete pandas, and then we'll move ahead. But yes, now if you have any questions, please put in the chat. In case if you do not have any questions, I have shared the feedback link. I request you to please provide the feedback. So if you liked the class, please provide the feedback. Please rate it 5. And in case if you are having any other thoughts, you can rate it any score that you would want to. But 5 is termed as good. Rest everything is termed as not good. You are also free to provide in your comments. And then yes, of course you can drop. Thank you. See you tomorrow. And in case of any questions, please put in your questions. Then you can provide the feedback and the drop. Sure, let me share the code again. Shabazz. I'll be uploading the code for pandas tomorrow on the LMS portal because it could be that in tomorrow's class we might make multiple changes, and then I would want to, of course, upload a final version of the code rather than me sharing today as well as tomorrow. Then you might get confused which code to use. That's why. Yes, of course. Let me unmute you, Toby.
Yeah, Rahul, thank you very much. So let me just quickly show you something. Can I share my screen, please?
Sure, sure. Of course. Let me see if the settings are enabled for that.
Okay.
Give me a second. Let me enable those settings if they are not. Yes, you can share your screen.
Can you see my screen?
Yeah, this it's coming up. Yes, visible now.
Yeah, I'm a bit confused here in this line 169, this pivot table, because if we have the table like this and we have tip and bill, so these values here we have Friday 312. So under which area does this what's it called? These values fall under, because the table, the columns looks a bit confusing for me, and I'm not able to categorize. Okay, where does this value fall under? Does it fall under no, yes for each of these tip or total bill?
Okay, got it. So let me share the screen and I'll make it. I'll draw the annotations and show you how this refers to.
Okay,
Okay.
thank you. Yeah.
Mhm. So I hope my screen is visible.
Okay, yes, it's visible now.
So whenever you are having multiple, see, for when this kind of look would come up, when you're having multiple values, okay,
Mm.
then is when this would usually come up. And in fact, multiple columns as well, then is when it will come up. So always how it is defined, like tip column. So tip is divided into no and yes, because we have five in this smoker column over here. So same way, total will divided into no and yes. So always the last on the top of the last column is where the tip, like the column name is given. So how this is divided like this. So for tip, no, these are the values. For tip, yes, these are the values. For total bill, smoker, no, these are the values. For total bill, smoker, yes, these are the values. Does it make sense? So when the gender is female, Friday, person is not a smoker. So the average tip is 2.3.125. Of course, confusing to look at, but yes. Okay, let me allow you to unmute. I think you muted. So clear on this, Toby, now?
Yes, it's clear. Thank you very much. Thank you. I appreciate it.
Perfect.
Thank you.
Thank you. Okay, so any more questions, anyone? Please put in. If no, request you to please provide the feedback. It is helpful and necessary. If you like the class, please rate 5. If you did not like anything less than 5. Thank you, Toby. Thank you, Kinder. Thank you, Sundar. Thank you, Siddharth, Vasu, Vaibhav. Thank you. Thank you, Jay. Thank you, Pratik. Thank you, Bharat, Mayur. Thank you, Aparajita. Thank you, Faizan. Thank you. Perfect. So I do not see any questions coming up. So thank you, Nushad. Thank you, everyone. See you in tomorrow's class then. Till that time, have a good day. Thank you, guys. Bye. Leaving the session.
Thank you for a wonderful session, and thank you everyone for your participation. Once we wrap up the session, you can see survey feedback from in your browser. Please rate us the session between 5 or less than 5. It will improve the upcoming sessions. Thank you.